Hello and welcome back for another VMK in the C++ series. In this VMK I'm going to describe static members and static functions. These pertain directly to classes, so make sure you've gone through at least the previous VMK to see the differences between regular structures and classes. Let's get started. Inside Visual Studio here we're going to create a new project. Going to create a console Win32 project. I'm going to call this static. Under application settings we're going to use console application. We're going to click finish, and in here we're going to go through and do the following. I'm going to create a class, and it's going to be a very generic class. I'm not going to have any details in here at all, but I'm just going to use this to demonstrate how to use static variables. So I'm going to call it car, and we're going to create a public constructor. And in this constructor we're going to have a member variable which is just going to contain the number of wheels that this car has. And by default this car is going to be a four-wheeled vehicle, so it's going to look like so. We're not going to have anything private, so I'm just going to leave this guy blank. Then we're going to have my divider here, and finally we're going to have our member variables. Like so. Alright, what this tells me is that every time we create a new car object, it's going to have a member variable called I number of wheels, and it's going to be set up to be 4. Now inside my main program here, what I'm going to do is create 4 car objects. So I'm going to call this cars, and we want 4 of them. We want to display to the screen how many wheels each of these cars have. Cars I number of wheels, and then what we're going to do is select one of the cars, doesn't matter which one. Let's say we're going to select the second one, and we're going to take the number of wheels this car has and just change it to be 2. And then we're going to print out the same thing we did before, and right at the very end we're going to just print F some extra carriage returns to the screen. Alright, let's try this program out. So we have, well, actually let's put an extra carriage return in here to clear things up a bit. Alright, so the first 4 are belonging to the constructor here, so all of our cars have 4 wheels, and then we set the second car to have 2 wheels, so we see 4, 2, 4, 4, and then we just return. Alright, this is the way that a regular class here would define its member variables. Now if we wanted to create a static variable, all we need to do is type in the keyword static in front of our variable. As soon as we do this, this variable now is static between all car classes, which means all the car classes that we create are going to have only this one variable. Each of these cars will not have their own number of wheels variable. They'll all share the exact same variable used in common between all of them. If we try to compile this program right now, we see that it actually succeeded, which is surprising to me. So let's give it a run and see what happens. Okay, it didn't run because there is a bug in the program. Let's see what the problem is here that it gives us. It says static int cars m underscore I number of wheels is an unresolved external symbol. What this means to the compiler is we can compile the program, but we cannot actually build it and run it because the linker doesn't have a definition for this member variable. Because it's defined to be static, that means that every single car class that we create is going to be using this variable, but this variable hasn't been allocated any memory. So we need to do that before we can actually run this program. And the way we do that is we can go in here and say it's going to be an integer because we've defined it to be an integer, and we need to allocate it some memory. So it belongs to the car class. We give double colon here and we specify the name of the variable. Now here we specify how many wheels our car is going to have. Well, we know we want it to have 4, so we're going to define it to be 4 like so. We can also get rid of this constructor here because it's not going to serve a purpose for us. Now if we compile our program, it succeeds, and if we build it, it also succeeds. Let's give it a run. Notice what happens now. We have 4 wheels because by definition here we've set it up to be 4, but whenever we went and ran our program, we've changed the number of wheels for the second car to be 2. But notice what happened to all the other cars. Car number 1, 3, and 4 also now have changed the number of wheels for themselves to 2. This is because our variable is static. So again, if we are using a static variable, this variable is shared among all car classes because it is static. And the value of that variable we can change just the same way as we've always done, but we need to make sure we allocate memory for it so that the compiler knows where to store this variable in memory. It no longer belongs to this car class, it belongs into this global memory space where it's being used. Similar to having static member variables, we can also have static functions. Let me demonstrate how these work. Let's say we create another variable m_b flat, and by default we're going to set this guy equal to false, meaning we don't have any flat tires. Now if we wanted to create a static function, we're to use the same thing that we did before, static keyword, and then we have a return variable. Let's make it void, and let's call this function change tires. So we're going to use this function to change the number of wheels that are, well, I guess I should call this wheels then. Change wheels. We're going to use this guy to change the number of wheels that are contained on our car, like so. If we go and build this program, you notice everything works fine, and we have the option to go in here and instead of accessing our member variable directly like so, we can now do change wheels and specify this to be 2. Everything seems to work fine. The advantage of having a static function is that we can actually call this function before we even have a car object. So you notice here we have a car object that we're calling that change wheels function on. What we can do is call this guy before we even create a car. So up here, the way we can do this is we can say we want to call a function that belongs to car. So we do this, and we specify we want to call the change wheels function, and here we want to change the number of wheels to, well, let's make it 3. We have some sort of strange 3-wheeled vehicle. Now when we run our program, notice what happens. Our constructor automatically takes the new 3 value that was passed into our change wheels function. And it knows that all of our cars that we're going to be creating are going to have 3 wheels. So then when we do create 4 cars, all of them have 3 wheels. So that's how we can do, this is how we can access static member functions. If we remove the static keyword there, we cannot do this anymore. You'll notice that as soon as we try to compile, we see illegal call to non-static member function. It doesn't let you do this unless it's a static member. Oh. The other thing with static members is that if you have a static function, you can only access static members. For instance, if I wanted to change this variable here, which is not static because it doesn't have the static variable in front of it, maybe I wanted to make all my cars have flat tires. if I try to do this, we get build errors saying that illegal reference to non-static member, m_b flat. You notice that my static function is not able to change non-static variables. Only static functions are allowed to change static variables because of the way that the C++ structure works with static variables and functions. So hope that clarifies some things on how static functions and static variables are used and when you would really want to use them. They are very handy, but they can be overused. By using static members and static functions, if you start overusing them, you can break down the overall structure of how a class works and therefore really degrading the performance of your code. You don't want to use these too much, but you do want to use them in specific cases when they are needed. And it's really hard to describe when you should be using them and when you shouldn't, but I did want to show you how to use them in this VMK. So if you do have specific questions on static functions or variables, feel free to go to my website and under the community forum sections, post your questions about them and I'll see if I can answer them for you.